Bismillahirrahmanirrahim. Assalamualaikum and a very good day to the panels. I hope you guys doing well during this pandemic. Before I start my video presentation, my name is Arif Warizbin bin Mazlan and I am about to present my project title, that is the behavior of railway baseplate under the supervision from Dr. Abdul Malik bin Abdul Wahab. Before we get deep into our topic, let me explain about the introduction first. So, what is baseplate fastening system in railway track? Have you ever wondered that what is the system that they use in order to hold the rail onto its place? So, the baseplate fastening system in railway track is one of the system used in railway track. It is used to hold the rail and lock the rail onto its place in order to ensure that the rail do not have any movement occur. And to be specific, it is placed between the rail and railroad, which normally it fixed to the sleeper by railroad spikes or rail bolts through holes in the base plate. So as you can see on the diagram, there is a numbering in the diagram. For the first number is rail and second is bolt. So the using of bolt is to ensure to lock the base plate firmly and strongly, and the use of clip actually is a key for a bolt. And for the 4 is support and 5 is rail pad. So the use of rail pad actually is to absorb all the forces that come from the train, especially vibration forces. And number 6 is base plate, that I will try to explain in this video presentation. We move on to literature review. For the first subtopic in this literature review, the influences of baseplate in railway track. So the influences of baseplate in railway track actually it prevent the rail from moving, as I have mentioned earlier, and it can also create that smoothness and comfortness right to the passenger in the train. And next point is the optimum value of stiffness can significantly reduce, and also it also can slow the deterioration of the track. So by having an optimum stiffness, actually it can reduce the degradation of track. Next, baseplate also help to reduce the vibration at the rail due to the movement of the train along the track. So this is one of the advantage by using the implementation of baseplate in railway track. For better understanding, the diagram shows how the vertical forces act on the rail. By focusing on the compressive load, this is one of the forces that can causes the failure occur on the base plate itself, that I will mention and then I will explain later on. When it comes to the track deterioration, it is commonly happen in railway lines. There are two main effects that contribute to this problem. First, it is about the climate, and second is due to the traffic of the train itself. But I am not going to touch about the climate. What I am trying to explain in this presentation is about the more on the technical problem, which this problem mainly causes from the wear and fatigue. These effects actually comes from the contribution from the static and dynamic loads or forces on the track. Next, we move on to the material polyurethane versus metal base plate. Both of these material actually is widely used in modern railway track right now. To make a comparison, the polyurethane actually have the best characteristic if you want to compare with the metal. First, polyurethane have the lightweight. Second, it has high strength to weight ratio. It has less time production, which is save the time. And the most important aspect is it have the vibration reduction, wear resistance, and compression resistance. Compared to the metal, it is heavy in weight. It low strength to weight ratio, and it difficult and takes more time production, and finally it tends to get rust. So, to conclude this subtopic, it shows that the polyurethane material is one of the best material in order to make an implementation in railway track to reduce the impact of vibration forces or any forces that can lead to the failure of the track itself and also the base plate. Next, we move on to our last subtopic, which is failure analysis in base plate. Actually, base plate, it can deform and it also can fail, all right, due to the high impact of loads that exerted on the rail. In order to reduce this kind of problem, there are some research that I have been read, and for the first method that they have proposed is by having a limitation maximum speed of vibration in ballast within it should not exceed within 15 to 18 millimeter per second. It actually can reduce the track degradation or track deterioration. Other studies also in France railway track, they have proposed that by using base plate as twice as thick as the normally thickness that they use, actually also it helps to prolong the life cycle of base plate itself. Next, there are also a study have shown that they recommended to increase the mass of the base plate rather than use low mass in order to increase the quality of ride. So in this point, it shows this study have show the graph of deflection, and the graph shows that a little deflection on the rail by implementation the increasing of mass rather than use low mass, and also this can help to reduce the failure in base plate. Alright, so speak about the stiffness track in railway track. So the stiffness actually it's really hard to understand because it is a non-linear studies. So the low global stiffness track will experience large displacement and large bending moments, while high stiffness track will experience small displacement and small bending moments. Actually, if we implement the high stiffness in track, yes, it can small displacement and have a small bending moments in rail, but it actually can increase the rate of deterioration in the track. While by implement the low stiffness track in rail, actually it can reduce deterioration of track, but the negative impact is it experience large displacement and large bending moments. Alright, so this is very important. The stiffness studies is very important. We need to propose the optimum value stiffness of base plate in order to increase the life cycle of track and the base plate, and to reduce or to prevent any failure occur in the base plate for a short time. So, for better understanding, this is a diagram shows on how the system works in the railway track. So the rail mass and if you can see on the diagram, the wheel rail and the rail mass will contact. That this it shows that the vibration or the forces of vibration will occur due to the interaction forces, due to the interaction dynamic and static forces that occur in railway track. For the problem statement, previous studies have shown the importance of base plate in rail fastening system. However, there are only a few studies using 3D finite element to show the behavior of base plate in fastening system of rail. Thus, this study focuses on the static stiffness of the polymer base plate fastening system. Let's move on to the objective. So the objective is quite simple. First, it is to create a model of base plate by using finite element method, and second, to investigate the static stiffness of the base plate. Again, like I have discussed earlier, the stiffness is really important in track in order to prevent or to prolong the life cycle of track and base plate itself. Next, for the scope limitation section, it is covered only on slab track, the polymer base plate materials, and the modeling by using SolidWorks and ANSYS software. For the final discussion, I will touch a little bit about the methodology. As you can see on the slides, I have constructed a flowchart in order to monitoring the process of my work in order to achieve the objective. The project stages, it is more for stage 1, it is more on the literature review, and extensive study on the behavior of base plate fastening system have been reviewed by myself and with the help of supervisor in order to have a better understanding in this topic. So for stage 2, I will create the modeling, the base plate and rail by using the SolidWorks and ANSYS software. And for the stage 3 or final stage, the justification and validation of the result will be made. For the expected results, the result will be shown on the graph of stress and strain diagram and force deflection or displacement diagram to determine the optimum loads applied before it starts to get failure. The diagram shows the force displacement diagram, which the higher applied forces on the rail itself, it actually will causes the increment of displacement or deflection of the rail, and which this problem actually can affect the base plate itself that connect with the rail. As you can see on this slide, this is the expected analysis and modeling of the rail and base plate fastening system that I try to achieve by using the ANSYS software and with the help of SolidWorks software. So I think that's all from me. I hope that my explanation throughout this video will give a better understanding to the viewers and of course to the panels on the behavior of the base plate fastening system in railway track. Thank you very much.